Hey, all, today we're going to continue talking about right triangles. We've talked about the Pythagorean theorem. We use the Pythagorean theorem to find missing sides if you know two sides. We talked about special right triangles, and in special right triangles, you really only needed to know one side length to find the other two side lengths, but you need the angles to be 45 and 45 or 30 and 60. But now we're going to talk about a way to find missing side lengths if you don't have special right triangles, and perhaps you only know one of the sides, but you do know the angles. And so that's called trigonometry. And so before we get started, what I want you to do is I want you to open Desmos. So pause if you need to open Desmos. And now that you're in Desmos, I want you to go click this wrench over here that says graph settings. And I want you to go down and make sure the word degrees is grayed out. We want our calculator to be in what we call degree mode. Otherwise, when we use the calculator to do some solving, it's going to give us some answers that look incorrect because we're in the wrong mode. So make sure your calculator is in degree mode. I think that's standard, but let's just make sure. So I refer to these things as trig ratios, trigonometric ratios. Trig ratio sounds better. There's three of them that we are going to talk about. And what they really are, even though they have sort of complicated names like sine, cosine, and tangent, which we abbreviate as sin, cos, and tan. That's how you'll see them. They're just relationships between specific sides in a right triangle. And so in a right triangle, if we refer to a specific angle, so in this case, we're referring to angle C, whenever we write a sine, cosine, or tangent function, we always put the angle that it's related to next to sin, cos, or tan. So this is talking about the sine of angle C. So I like to go over here and maybe put an asterisk or a star or something in angle C to know that we are going to be writing our relationships based on this angle. And so this angle is adjacent to one of these three sides, which means next to. So that is the side it's adjacent to. I'm going to give it an A. There's a hypotenuse always in a right triangle. We call it H. It's across from the 90. And then we would say that there's a side that's opposite every angle in this right triangle. So the side opposite of the angle we're talking about is O. And this is kind of standard practice for me when I'm doing trig ratios, labeling the side that's adjacent to my angle, opposite my angle, and the side that's the hypotenuse. And I think it's really helpful because these three ratios are relationships using two of those sides. So my sine relationship or my sine ratio is the length of my opposite side divided by the hypotenuse length. The cosine ratio is the length of my adjacent side divided by the hypotenuse. And the tangent ratio is the opposite side divided by the adjacent side. And there are some ways to remember which are which. The one that works best for me is just writing them down a lot. We can talk about some ways to remember these combinations, but there's no better way to remember something than writing it down every time you use it, or maybe even extra. And so this question wants us to find the sine ratio for angle C. And I like to put the angles in parentheses because eventually those are going to be numbers. So since we have this labeled, I simply need to find the opposite side, 36. Sine is O over H, opposite over hypotenuse. My hypotenuse is 39. And that is my sine ratio. We would like to simplify it, which with the access to the calculator, we can do pretty easily. We type it in, we click the fraction button, it simplifies that for us to 12 over 13. And you should always do that, especially because we have the calculator. So these trig ratios, sine, cosine, tangent, All they are is a relationship between two of the sides in a right triangle. And so this is the ratio that these two sides are going to be in. In the next one, we're referring to angle X. So I can put a star in there, put something in there, whatever it is that will let you know, hey, we're referring to angle X. My hypotenuse is across from 90. The side next to angle X that's not the hypotenuse is always my adjacent side. And then my other side is my opposite side. So the O and the A are going to change based on which angle you're talking about. If we were talking about angle Z in this triangle, the O and the A would switch, which means your tangent value would switch. And so it's very important to set these up correctly because that will help you get the right ratio. If we want to know the tangent of angle X, we need the opposite side, that is 30. We're going to divide it by the adjacent side, which is 40. And then we can simplify that in Desmos if you want, or if you know it's 3/4, you should always simplify it. Let me do one more. We want to know the cosine of angle Z. This is angle Z. 45 is my hypotenuse across from the 90. My adjacent side is always next to that angle we're talking about. It's making that angle. And my opposite side is the remaining side. It's a little bit of process of elimination. Cosine of any angle is the adjacent side, A, which is 36, divided by the hypotenuse, 45. And then, of course, we can simplify that. 36 divided by 45. And we get 4/5. You should always simplify, especially because the calculator will do that for you. So it's important to have these written down somewhere. We can talk about some mnemonic ways to remember them. The best way to remember them is to write them down a bunch of times. Write them down every time. We're going to use these ratios to now solve some problems. So if you struggle with those ratios, before you move on to this step, make sure that you ask one of us for help. If you feel like you got it, or at least feel pretty comfortable, then move on. It's okay if you get uncomfortable with this at any point to ask for help. We're glad to help you and give you guidance. Here I want to solve for a missing side, X. I know one side length 11, and I know one of these angles is 70. And so this angle that's labeled is a bit like calling out the angle we want to write the ratio for earlier. So we are going to label our sides O, A, and H based on this angle 70 that we know how big it is. X is our hypotenuse. It's across from the 90. This side is making this angle. It's next to this angle. This is my adjacent side. And so that makes 11 my opposite side. And so we're not told what function we should be thinking about. What we need to do is we need to pick which one. Sine, which is O over H, cosine, which is A over H, tangent, which is O over A. Our opposite side is 11, and our hypotenuse is the side we're looking to find out how long it is. And so O and H tells us we can use a sine ratio. We can write a sine ratio, O divided by H. O divided by H. We're using sines. Sine is equal to O, 11, divided by HX. The angle is what goes next to that ratio name, and our angle is 70. This is actually something we can put in the calculator, but I'm going to wait for that. We can make this a fraction because we've been dealing with fractions, and we can cross multiply this fraction to start solving for X. Now, just so you know, sine of 70 is a number, and so we can treat it as one number, even though it looks uncomfortable. And we can solve. So we're going to do sine 70 times x is just going to look like this. 1 times 11 is 11. Again, that sine 70 is just one number. It looks uncomfortable, but we can divide both sides by that number. Cancels out over here. So x is equal to 11 divided by sine 70. Our calculator has the power to do that. We can do 11 divided by, and then if we go into our keyboard and select functions, you can see under trig functions, sine is an option. And we type 70 in there, and then we get a number. We'll call it 11.7. And that is approximately how long our hypotenuse is. The important thing is to make sure our calculator is in degree mode because we're measuring these angles in degrees. There is another measurement for angles called radians, which is why that's the other option, but we're not dealing with that right now, so make sure you're in degree mode. Let's do a couple more. I'm going to label this triangle my hypotenuse, my adjacent side that's next to it, and then my opposite. In this problem, I want to know the hypotenuse and I know the adjacent. That tells us to use cosine. So if we write cosine of this angle that's 65, it should be equal to my adjacent side, that's 12, divided by my hypotenuse, which is x. We can solve for x here. We're going to make this into a fraction by dividing it by 1, and we're going to cross multiply. So cosine 65 times x, we just write them next to each other. 12 times 1 is 12. Again, cosine 65 is just a number, so we can divide by it on both sides. Sorry for the messiness. That cancels there. And so we can actually go in the calculator and do 12 divided by cosine of 65. Cosine is in that functions tab. And we can get 28 point, we'll call it 28.4. We'll round that 39 to a 0.4, 28.4. And so again, we found the length of our hypotenuse. Let me do one more. Again, this takes practice. This is a new idea, completely new to us probably. So practice is what's going to make this more comfortable, and then asking for help will make it even better. Here I have my hypotenuse. I have my side next to it, my adjacent side, and then my opposite side. I want to know my opposite side, and I have a number for my adjacent side. Nothing is written here for hypotenuse, so I'm not interested in that right now. O and A make the tangent ratio. So I am going to use tangent here. I'm going to say tangent of my angle 58 is equal to my opposite side x divided by my adjacent side 20. So not 2A, 20. Again, I can turn this into a fraction by dividing by 1, and I can cross multiply. 20 times tangent of 58. And I usually put the number out front here, and you can put it in parentheses if you want to. X times 1 is just x. So what's nice is we could just put this into our calculator straight away. 20 times tan 58. So 20 times, and in our functions, we click tangent 58. And that's pretty darn close to 32. We're going to call x 32, rounding. So before you try one of these on your own, please do ask for help if you need it. It's important to label them O, A, and H. It's important to write down the possibilities so that you start remembering sine, cosine, and tangent, and then choosing the right one, and then solving. Plenty of places to make small errors, but if you're careful, you can do this. And if you need help, go ahead and ask. We'll be happy to do that. If you're ready, try these two problems, solve for x in each of them, and then check your answers. So hopefully you got these two answers. I wrote the equations that you should have set up to solve for x. If you get the equation set up, that's a really big step. If you got the equation set up but you couldn't get yourself to the answer, that's okay. We can find that problem. We can work through that. Please do ask for help though if you got one or both of these wrongs, so that before you go practice, you fix any errors that may have occurred. And then once you're ready, go ahead and do these practice. Like I said, a few times this lesson and a few times every lesson, please do ask for help if you get stuck. That's what we're here for. That's what we like to do.